Hello students, in this class we are going to discuss about data link layer protocols in unit 2. So as we already discussed about the basic, the primary functions of each and every layers in unit 1. So as we discussed in OSI layer model, so data link layer which takes the responsibility regarding how to convert a number of bits into frame, and not only conversion of frame, while it convert a frame from bits, so it has to add a MAC address for both source as well as destination along with the original data. Then it will add some of the control field. So in this control field we can have a error control as well as flow control. So error control field which helps you how to recover your message even though some error happen, and similarly flow control whenever the receiver or the destinator not able to receive your data. So for that time it has to send some control information to the sender station, so that it has to limit the or restrict the sending data rate. So in this class we are going to discuss about what are the flow control protocols are available, and it will how it is going to support for data link layer functions. So as we already discussed, so the data link layer protocols with respect to flow control, we are having two different kind of channels for noiseless channel as well as noisy channel. So in noiseless channel, so the name itself we can find there is no noise occurs, so it is not required to have any kind of the acknowledgement for sending the next data, so no need to wait for that kind of things. So if you have a data, you have to send continuously. In the case of a noisy channel, because we all transmit our informations through noisy channels only, and here we can implement the three different kind of protocols. Let me have a stop and wait, go back and select repeat. Let me discuss one by one. If you take a simple protocol, so simple protocol here it defines there is no acknowledgement, no need of asking any kind of the reliable information from the receiver side. Let me take here we can have sender as well as receiver. In sender, if you have a frame and it sends some request message, then if you have a get the acknowledgement, then immediately how to send a frame one by one. So here both parties doesn't have any kind of the acknowledgement or any kind of handshaking. So because if you have a frame, you can send continuously. And here the next protocol it will support the data transmission process for noisy channels. So stop and wait. So before sending the next frame, so we have to wait getting the acknowledgement from the receiver side. Suppose if you are sender, you have a 5 number of frames, and if you have a chance to send the first frame after getting the proper permissions or reply from the receiver side, and you can send a frame number 1 or first frame, and after sending a frame number 1, then you have to wait for getting the acknowledgement. So within the predefined waiting time, if you receive acknowledgement from the receiver side, then you have a chance to send the next frame, and vice versa. Suppose during the waited amount of time, so if you are not receiving any kind of the acknowledgement, so yourself you have to think, you can take a decision that particular frame gone lost during the transmission medium itself, so that you have to resend a frame again. So that is why the name is called a damaged frame. Suppose you have a data and you are sending a data, and if you are sending a data that frame doesn't reach the receiver side, okay, for that what we have to do, so we have to wait some amount of time, and if you are not receiving any acknowledgement, suppose acknowledgement means positive acknowledgement, suppose if you are not receiving positive acknowledgement, instead of that if you are receiving negative acknowledgement, okay, for that you have to identify the last frame whatever you are transmitted that should be lost, so that you have to resend the previous frame again. That is called actually damaged frame. But the last frame, so last frame is nothing but so you are sending a frame, that frame doesn't reach the receiver, okay, so that you can see here frame 1 is actually getting lost during the data transmission itself, so that you are not receiving any kind of the acknowledgement, still you are waiting for getting the acknowledgement for the previous frame. So now you have to take the decision, and you have to send the previous frame again, and compare while you compare the damaged frame as well as the last frame. In damaged frame, in this case, you are receiving the negative acknowledgement from the receiver. So it clearly indicates the receiver describes you about the frame not received. But in the last frame, the receiver doesn't send any kind of the negative acknowledgement. So yourself, you have to take some decisions regarding the last frame gone itself, disappear itself in the medium itself, so that you have to send a frame again. And the next protocol, we can have a go back and protocol. So while you compare this go back in protocol with respect to stop and wait protocol, in stop and wait protocol, each and every time of data transmission or frame transmission, we have to wait for getting the acknowledgement from the receiver side. But in go back and protocol, you can have n number of frames with you, and no need to wait for any kind of acknowledgement. So if you have a frames, let me take I can have 4 number of frames. I can have totally 4 frames, and I can send 4 frames continuously. After sending the last frame, then you can have the acknowledgement. So this protocol support more and more compared to the stop and wait protocol, because you are sending bulky amount of data at the same time. No need of waiting any acknowledgement. Suppose any during the data transmission process, if any loss happens, let me take here. You can have an example. You can have 4 number of frames. So frame 0, 1, 2, 3, and here while you sending frame 3, at the same time I am receiving some acknowledgement I am not receiving the acknowledgement for frame number 1, but rather than receiving acknowledgement for 2 as well as 3. So I can have 4 frames, and I can receive acknowledgement for 3 frames. Particularly frame number 1 acknowledgement I am not receiving. For that, even though I am successfully transmitted frame 2 as well as frame 3, but because of frame 1 not delivered successful manner, once again I have to resend from frame 1 onwards. So frame 1, 2, 3. So we have to resend from the last frame onwards. So this will make kind of the drawbacks, immediate drawbacks for the go back and protocol. So in order to avoid this kind of drawbacks, we go to the next protocol, that is selective repeat protocol. So in selective repeat protocol, whatever already we have discussed in the go back and protocol, the same way you can have n number of frames, and you are sending the same amount of frame continuously, and suppose your frame gone lost. So we have a chance to resend whatever the frame, the particular frame lost itself. So here I am sending frame 0, 1, 2, 3. So there will be a lost happen in frame 1. So where in the case of go back and protocol, I have to resend the last 3 frames, frame 1, 2, 3. But here I can resend only the last frame only, say frame 1 alone. Okay. So when you compare those 3 protocols, like go stop and wait protocol, go back and selective repeat protocol, the selective repeat protocol which gives takes good amount of propagation time, transmission time, and it will give minimum amount of delay. So this particular protocol always will be enabled in case of the data link layers. Thank you, students.